In this video, we're going to be covering question 3, part C from the 2019 AP Calculus AB free response, no calculator allowed portion of the exam. I cover A, B, C, and D all in their own individual videos, so if you want to see the other solutions, please feel free to check out my other videos. The first thing that I do on any AP Calc problem where I've got a graph in front of me is I make sure I know what that is the graph of. And so here what we have in front of us is the graph of f. This is the graph of f of x up top here. So then let's see what we're being asked in this problem. So they're telling us the function g is given by this equation right here. And then they want us to find the absolute maximum of that equation over the interval from -2 to 5. So two things to notice when you look at this. One is when you see that x sitting up top there, really what you got to be saying to yourself is this is going to be the fundamental theorem of calculus part 1 is most likely going to be involved in this problem. The only time you ever really see an integral on an AP Calc test that has an x or some equation in the bounds is when you apply that. And then the other thing we're looking at here is we're trying to find the absolute max. So to find an absolute max, this is a set of steps that you just need to go through and see where they take you. They're the same set of steps every single time, no matter if you've got a nice pretty equation to work with or something that has an integral. So they give us g of x is equal to the integral from -2 to x of f of t dt. Well, the first thing that we would do when we were trying to find our absolute max, the first step of our process is to find the derivative of this. So we're essentially ddxing both sides of this equation. On the left side, that's just going to be a notation game. The derivative of g of x would be called g prime of x. On the right side here, that's where we're going to be applying that fundamental theorem of calculus part 1. Derivatives and antiderivatives, they're inverses of each other. They cancel each other out. It's like squaring a square root. So what happens on this right side here is my derivative and my antiderivative cancel each other out, and whatever is up inside there is just going to drop into my equation. So what I can see is that my g prime of x is equal to f of x, and that is the graph that I'm looking at over here. So this is the graph of f. It is also the graph of g prime of x. Then step 2 of the problem is I want to find any critical values. So I want to know when does g prime of x equal 0 or when is g prime of x undefined, does not exist. So looking at this and looking at my graph now, where it equals 0, this is 0 right here. Remember, I want to know when does that graph equal 0, because what I'm looking at now is when does the graph equal 0. And I can see that the graph is going to equal 0 here at x equals -1. That's going to be a critical value. Then we have this point right here, which I love it when they want you to assume something, but they want us to assume that that's halfway between there. So we also have a critical value at x equals 1/2. And then we've also got this critical value happening down here at 5. But that also was one of our endpoints. So from there, once you've got your critical values all put together, then step 3 of the process on an absolute max min problem says plug in all critical values, I'm just going to call them CVs, and endpoints of your interval back into the original function. And what we do from there is we compare those values to see which one, in this situation, because we're looking for the max, which one has the largest y value. So we've got our critical values listed up top here, and then we have our endpoints come from the interval that they gave us. So we've got an endpoint happening at x equals -2, and we have an endpoint happening at 5, which we already got out as a critical value. So we are plugging these back into the original function here. So we come through and we would say, okay, I want to know what is g of -1 equal? What does g of 1/2 equal? What does g of 5 equal? And then, so those are all my critical values. And then I also need to know what does g of -2 equal, the other endpoint that wasn't included up above. And so here, this is just function notation. Function notation works the same no matter if you've got a pretty equation to plug things into or if it's an integral function. So we're using that original function. So this would be g of -1 would equal the integral from -2 to -1 of f of t dt. And so when they don't give us an equation to work with from our integral, then what they're wanting us to remember is that the integral is the area between the curve and the x-axis. And generally what they want us to do is use standard geometry formulas to find that value. So this one's going from -2 to -1. So what we're looking at up here is this little triangle right there. So you need to know the area of a triangle formula. The area of a triangle would be 1/2 base times height. So in this situation, the base of the triangle is our gap between -2 and -1. So that's going to be 1. The height is going to be where we end up getting right here. The height on that would also be 1. So we know that when we plug in -1, we get out the value of 1/2. And now we just keep playing that same game. On the next one, we're going to go the integral from -2 to 1/2 this time of f of t dt. And now when we come through, now we'd say, okay, I'm going all the way over to this position here of 1/2. Well, what you want to be able to kind of identify quickly is the fact that this area down below here, that area is going to cancel out with that triangle up above. Remember, area above the x-axis is positive area. Area below the x-axis is negative area. So those two things are going to cancel out. And that first chunk right there, that's really just going to give us a 0. And then we need to add on this last little remaining piece here, which is another triangle. So we would add to that a 1/2 base times height. This time we would have 1/2. I'm just going to drop the 0 because 0 plus anything is 0. Our base is going to be that gap right there of 1/2. And then our height is going to be coming down here. That's going to be -1. And that's how you can kind of see where you get above and below give us positive and negative. So 1/2 times 1/2 is 1/4 times -1 gets us -1/4. And then we keep coming through the puzzle here and we'd say, okay, plugging in 5 now. So the integral from -2 to 5 of f of t dt. So that's going through this full gap starting here at -2, ending over here at 5. So that full area right there. And we actually did this. If you want to go back to part A, you would have done this work already on part A. And we got that out from our previous video. And so I'm just going to grab that work from up above. And that previous work tells us that the answer for that full integral would have been 11 minus 9 pi over 4. And then the last integral here that we got to figure out is what happens when we plug in -2. So this would be the integral from -2 to -2 of f of t dt. Well, this is one of those ones when your bounds match up, no matter what's going on with your integral, when you have matching bounds, the answer to this is always going to be 0. So from here we come through and we kind of look at what would our largest y value be technically in this situation. It wouldn't be our -1/4 and it wouldn't be our 0. And as we compare these two things, 1/2 to 11 minus 9 pi over 4, you can see that even though we've got some negative space, that there would be a whole bunch more positive coming through when we do that full integral from there. And so this value here is going to be what our absolute max would be on this problem. And so the absolute max value, you would say in the end, is 11 minus 9 pi over 4. And so on this problem, we would have gotten 1 point out from telling them, doing this work up here, showing that the derivative of g prime is equal to f of x. We would have gotten out 1 point for showing our critical values, and then we would have gotten out our final point by getting our final answer here using this method of plugging in our values until we found what we were looking for.